Titan is unique. It is the only other place in the solar system that we know of besides Earth that has a water cycle with clouds, rain, rivers, and even seas. And yet, it's very unlikely that Titan's water cycle can last forever. I mean, sure, Titan has plenty of water ice, so there will be no shortage of water. But Titan also has an atmosphere, and that atmosphere is full of methane. And that methane is constantly being lost to space because it breaks down when exposed to sunlight. So Titan's methane cycle can't last forever unless something is refilling Titan's methane supply. But what could that be? We tend to think of planets as fully formed objects that just hang out in space doing their thing for billions of years. But planets are still very much evolving. They still have active geology, meaning that they change over time due to internal heat. Some planets like Earth have whole-body convection, where heat from the core slowly rises to the surface. And Mars might have had whole-body convection in the past. Other planets like Jupiter and Neptune and maybe even Saturn have more complex convection patterns where different parts of the interior move independently. Now, this internal heat is super important because even though planets don't make their own light, they still radiate heat. In fact, Earth radiates way more heat into space than it gets from the sun, and this is why Earth doesn't freeze despite the fact that the sun only provides us about 34% of our energy. We use some of that energy to maintain our water cycle, which is great because otherwise we'd be a frozen popsicle. But Earth's internal heat also drives other geological processes like plate tectonics and volcanic activity. And while these things aren't essential to Earth's water cycle, they do play a role. For example, volcanoes emit water vapor directly into the atmosphere. But our favorite example is how Earth recycles carbon. The carbon in our bodies and in the stuff we use every day like plastic or gasoline originally came from deep within Earth. When volcanoes erupted, they released carbon dioxide and methane gas into the atmosphere. This carbon then reacted with oxygen and water to form dissolved organic carbon in the oceans. Over millions of years, this carbon was incorporated into shells and skeletons of marine organisms and eventually turned into fossil fuels. And then we burned that fossil fuel, and now all this carbon is back in the atmosphere, causing the climate crisis. So if Earth can recycle carbon, then maybe Titan can recycle methane too. In fact, scientists have found evidence of recycled methane in Titan's atmosphere. It's actually really easy to spot because the methane up there isn't exactly pure. It's got lots of heavier versions of methane mixed in like methane with one extra hydrogen atom. These different forms of methane absorb different wavelengths of light, leaving distinct spectral signatures in Titan's atmosphere. Scientists have been studying these signatures and have concluded that this heavier methane isn't just created at the same time as regular methane. It's made at a later time by some kind of chemical reaction. And just to be clear, we're talking about methane in the atmosphere here. There's also methane in Titan's liquid reservoirs and maybe even underground. And while we think this underground methane was produced during Titan's formation, it seems likely that some of it is also being replenished by methane that seeped down from the atmosphere. And that atmospheric methane would have come from somewhere. So, where does Titan's methane come from? One promising candidate is its surface. Titan has a lot of hydrocarbons on the surface, thanks to the fact that its atmosphere is full of molecular nitrogen, and that nitrogen rains down onto the surface in the form of solid nitrogen snow. Once on the surface, this nitrogen can react with methane and other hydrocarbons to produce heavier hydrocarbons and replenish the methane in the atmosphere. Now, scientists estimate that this alone can't account for all of Titan's methane. So it's likely that other subsurface reservoirs of methane are also being released into the atmosphere. One way this could happen is through a process called abiotic hydrocarbon synthesis, or AHS, which doesn't require life to produce organic matter. On Earth, Oz happens near deep sea vents where super hot water reacts with rocks to produce methane and other hydrocarbons. Now, Titan doesn't have anything like deep sea vents, but based on what we know of the chemistry involved, scientists think that on Titan, water and rock could react to produce methane even without the help of biology. The question is, how do you get those two things to interact? Well, you need water and rock to be in close contact, which means you need a porous rock layer and liquid water. And we think both of these things exist on Titan. Based on data from radar experiments conducted by the Cassini spacecraft, scientists think Titan has a layer of fractured rock about 100 kilometers below the surface that could hold liquid water. What's more, the rocks that make up this layer, called the cryovolcanic complex, are thought to have been heated by tidal forces caused by Saturn's gravity. In other words, this rock could be warm enough to facilitate methane production. So could this particular layer of rock be the source of all of Titan's methane? Maybe, but there is another theory. You see, the cryovolcanic complex isn't the only possible source of water. There's also the liquid water ocean beneath Titan's icy crust. And not only could water from this ocean make its way into the crust and produce methane there, but any methane produced could find its way back up to the surface via cracks in the crust. Now, we haven't actually spotted any methane coming from the ocean itself, but that's mostly because we haven't looked hard enough. Most of the observations we've used to study Titan's methane cycle have been taken from above. Future missions like NASA's Dragonfly will finally give us the close-up views we need to learn more about the sources of methane on Titan. And it's not just the location of these potential methane sources that remains uncertain. We also don't know how big they are. The amount of methane that could be produced by reactions happening in the crust or in the ocean depends strongly on how much water and rock is involved, which in turn depends on the size of the reservoir. Is it a small pocket of water or a vast underground lake? It all makes a difference. Now, I should say that these various sources of methane might not be mutually exclusive. Titan could have multiple places where methane is being produced and released. And to complicate things further, methane isn't the only thing that could be refilling Titan's methane cycle. If enough ammonia is present, it could theoretically slow down the breakdown of methane. And we think that ammonia does play some role in maintaining Titan's methane cycle. But whether it's enough to prevent the gradual loss of methane remains unknown. There's a lot that we don't know about Titan, but that's part of why it's so exciting. It's so unique that it gives us a new perspective on our own planet. And the more we learn about it, the better we lines understand how worlds evolve and how life might arise under very different circumstances than here on Earth. Thanks for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So, to all of our patrons, thank you for what you do to make this happen. If you're not a patron, but you want to learn more about what that means, you can go to our support page.